Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 1372, longest zigzag path in a binary tree. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking? You just need to return the longest zigzag path in a binary tree. To understand it better, let's take an example. So this is a binary tree you are given. Let me draw it. So this is a given binary tree. So what is a zigzag path? If we took left, we cannot take left again. We will not take left again. So what we will take? Right. Then again, we cannot take right again. Right again. What we will take? A left. Then we cannot take a left again. What we can take? A right. And again a left, and we reach to a null. And this is the path that we traversed. We started from here. This is the path that we took, and as you can see, I have highlighted the path length is node visited -1. So how many node you visited? 1 2 3 4 5. So 5 minus 1 4. And if we take this instead of left, if we take this right, so how long will the path be? So if we take right, we cannot take a right again. We will take a left. We will have a null. And so what will be the path? This will be the path. And what is the length? 2 minus 1. We visited 2 nodes. So just 1. And among them, which one is greatest? I would say 4. So we will return 4. This much is clear. This is how we will traverse the binary tree given to find the zigzag longest path. So there is one thing to observe, that when we do traverse it, we require a previous direction, or you can call parent direction. Why? Because without it, we cannot decide that after it which direction we should take, because we know we did take a left, so we have to take a right now. So there is this indicator that which will show that in previously, we took which direction, because it depends on it. In the current node, we will take which direction, it depends on the previous node, as you can see. This much is clear. And also, how we gonna calculate the length? We will have the count while traversing. This much is also clear. That's how you do in typically any length finding kind of question in tree or graphs. Basically in binary tree we are doing. This much is clear. And what else? And you can see we have to take both direction. We will take both direction, left and right, because we don't know in which direction we can have the largest zigzag path. We don't know. This much is clear. These are the 3 observations from here. There is one more observation that we have to do. So let me get that test case for you really quick. zoom it out a bit. This is the test case that I am talking about. So let's just traverse it to save time over the picture only. So what I did told that we will take left and right both, left and right. So we did take left, nothing. We took right. We took again a left, and after that end. This is the path length. This is not the longest path, but I said we can take left and right every time. We can take left and right every time. We took left because we wanted zigzag. Now if we say we don't want zigzag for now. If we don't want zigzag for now, what we can do? We can take again a right. And another thing, we are having number of nodes counted. We are having number of nodes counted. So when we take this kind of decision, we have to reset it also. And what to reset? To 1, because we are taking decision over this node, so this must be visited only. So that's why we will reset it to 1. And we will do again left and right, the zigzag. So we took right. Now we take again a left, then a right, and then a left, null. And in this case, how much is the length? This is the longest that we can take. How much is it? 3. 4 minus 1, 3. You will say we can take right over here. Take right. 1. We took a right. First 1. Then again a right. We just again reset it to 1. And again we are over here and we did a left. So how much is it? 2, because we did take a right over here. A right and again a right, so we did reset it over here. Similar thing can be done over here. We again reset it. Now it's 1. And again, how many nodes we visited? So 2 minus 1, 1, 2 minus 1, 1. I hope 3 is the largest. Not hope, it is the largest, and it is also the answer. So that's what we are doing. Taking the previous direction, traversing, while traversing, having the count, taking both left and right, and that's it. That's what we are doing. And you can see, if the previous direction, we took previous direction again. If we took previous direction again, then reset it to 1. Already told you why. I hope this much is clear. And we will be taking left and right every time. So what is the algo? We will be traversing it. You can take DFS and BFS. Particularly we will be discussing DFS. After that you can write BFS. That's up to you, but DFS is easy and intuitive. You can reproduce that in even interview also. And we will take left and right call because we don't know that which one will fetch us the maximum, and while traversing it, if we took same direction again as previous direction, what we will do, we will reset it to 1. But if we took zigzag, what we will do, whatever are the nodes plus 1, as you can see over here, we reset it over here, we just reset it to 1. Then when we visited this, again a plus 1, again a plus 1, again a plus 1. So how many nodes we visited? 1, 2, 3, 4. 4 minus 1, 3. That's what we are doing. Let's see the code. Here is the code. We are indicating left by 0 and right by 1, and we are doing both left and right over here. As you can see, this is for number of nodes. Initially it is 0. This is the solve function. We are taking max length of a global variable because we don't require, not required, it is easy because we have to send it again and again in the loop, in the recursion, sorry. If it is a null, we just return it and we keep on calculating it, the max length. If it is greater, if max length is less than current length, we will just update the max length. Quite trivial. And what we are doing, we are going left and indicating that we did go to left. And what is over here, what is we are doing, what are we doing over here? What are we doing over here is, if the previous, as you can see, previous parent direction or previous direction, if it is left, not left, sorry, 1 is indicated with right, my bad. If it is right, a 1, a true value, then we will do a plus 1 because we are following a zigzag path. As you can see, we are over this node. I draw it incorrectly. Yeah, we are at this node and we did took our right. So previously we did took our right, now we are taking left. Now we are taking left. What we have to do, if it is 1, we have to count it. We have to count it this plus 1 also. So 1 plus 1, 2. That's what we are doing. We are increasing the current length plus 1. If there is case like this, we took a right, then we again took a right, then a reset condition. In that case, I just explained it wrong. What am I doing? If we took left and again we are going to left, as we are going to the left in here, I just explained it wrong over here. I did make a right call. I am saying if we have a left, previous left, then there is a reset. That's simply it is. I just made a mistake in the drawing. If it is again a left, because in the current node we are taking left, only thing depend is if we took a right or if we took a left. If a right, current node plus 1. If we took a left, reset it to 1. Same thing is happen over here. We are taking a right, no matter what we are taking a right, but it depends. If we took a right over right, we took a right over right, then a reset, and we are indicating right with a 1, so +1, as it will be a true, and in the case of true this will be executed. And if we took a left then a right, I am drawing wrong. We took a right then again a right, it's a reset. And if we took a left then a right, then we will add current length or current node +1. My bad, I did this mistake 2 times. And after doing that, we'll just return the max length. Let's dry run it. Let me have the code. This is the code. Let's have the test case. This is the test case. We are taking both a left and right call. So for the very first time, we'll having a 0, current length 0, and the root. So what we are doing, it is not null. Currently it is 0. Nothing will change, and we are taking a left call. We are taking a left call, and what we are sending, a left call. We are sending a left call. We are taking a left call. We are sending a left call, and checking if the parent direction. What is the parent direction? A 0. So this will be executed. We initialized it with 1. We initialized it with 1. Now again recursion call. We did again go to left. We did go again to the left. Now if we took a left again, and you can see here another call, max length will be updated. Now it's to 1. If we did again take a left call, what it will give? Again a 1, reset 1, a reset 1, and we do a left again. We do a left again, and we get to a null, and in null we just return. You can see over here we just return. And when we return, what we do, because right call we didn't make, we will do a right call over here, and we will send a right. As you can see, right call, we will send a right, and we will check what is the parent direction. Parent direction was 0, so we will execute this current length +1. What is the current length? Over here it was 1, now it is 2. This 0 will handle that node -1, so no need to worry. Node -1. We will go to the right. We are over here. Then for here we will make a left call. We will make a left call, and here it updated. We took a left. We send a left, and we updated left, and we again did a left call. And by the way, it was 1, then it went to 2, and then it went to 3. Again a left call. We have a null. We just return it, and over here we again do a right call. Again do a right call. Again do a right call, and after that a right call, and again a left, null, backward, again a null, backward, and you can do the backtracking, and you can see how many nodes we did traversed. 3 is the highest. As you can see, when we go to this call, then +1 is happening. You can see. So here +1 happened. If you are little bit confused about the counting, here +1 happened, again +1 happened, and in this case again +1 happened. Because here we did a reset. You can see we did a reset. I got confused in between. How was the counting going? Yeah, it is 3. Now again we visited a 4 and we just return the 4, and you know this is the max we will get, and after that we will just return it, and that's it. And let's submit it and see if it is running or not. Yeah, it is running, and I hope I was able to make my intuition pretty much clear, and if I was, consider subscribing to the channel, liking this video, and in the end you have to do what you have to do. So keep grinding. You guys are awesome. See you in the next one. Bye bye.